In this video, I am going to discuss about preparation of alkanes. Preparation of alkanes from carboxylic acids. From carboxylic acids. Here we have two methods to prepare alkanes from carboxylic acids. The first one is decarboxylation of sodium salts of carboxylic acids. RCOOH is the general formula of carboxylic acid, and the second one is the named reaction, that is Kolbe's electrolysis. Kolbe's electrolysis. So let us discuss the first one, that is decarboxylation of sodium salts of fatty carboxylic acids. So here D is removal, and we are removing the carboxy group, that is CO2. So the equation here is RCO2Na. The reagent that is used here is soda lime, NaOH and CaO. This mixture of sodium hydroxide and calcium oxide is soda lime. So when you treat sodium salts of carboxylic acid with soda lime, then we get an alkane and sodium carbonate as the byproduct. So let us see with an example where we take CH3COONA, that is sodium acetate, and treat it with sodium hydroxide and calcium oxide, that is soda lime. Then we get methane and sodium carbonate. So here in the product we get one carbon atom less. So if we have two carbon atoms in the starting material, then we have one carbon atom in the product. So here if we take acetic acid, we are getting methane. For example, if we want to prepare, let's see, if we want to prepare propane. We want to prepare propane, and which acid we have to take to prepare propane by decarboxylation of sodium salts of carboxylic acid. So here we have 3 carbon atoms in the product, then 1 carbon atom more should be there in the reactant. So that is 4 carbon acid is CH3 CH2 COONA. This is sodium butanoate. Sodium butanoate, and with sodium hydroxide and calcium oxide we get propane as the product. So this is about the decarboxylation of sodium salts of carboxylic acid. The second method is Kolbe's electrolysis. Kolbe's electrolysis. So in Kolbe's electrolysis we use aqueous solution of sodium or potassium salts of carboxylic acids. Carboxylic acids. So here we use the sodium or potassium salts of carboxylic acids because your simple carboxylic acid is a weak electrolyte. If you take the salt of sodium or potassium salts of carboxylic acid, then it is a strong electrolyte, because these are the salts of a strong base and weak acid. So let us look at the equation where sodium salt of carboxylic acid, this is the aqueous solution, then we are going to get plus carbon dioxide plus hydrogen plus sodium hydroxide. Here I am taking 2 moles of the sodium salts of carboxylic acid, and we are going to get 2 moles of carbon dioxide and 2 moles of sodium hydroxide. So let us check with an example with sodium acetate, 2 moles of sodium acetate, and the aqueous solution, that is water, is added, and we get CH3, that is ethane, and carbon dioxide is evolved, and hydrogen and sodium hydroxide. So how this reaction occurs, let us see. So the mechanism of this reaction, goes by free radical mechanism. So this RCOONA, this is a general formula of sodium salt of carboxylic acid, that will ionize as this RCOO minus and sodium plus. So let us consider this with CH3COONA, that is sodium acetate. That will ionize as CH3COO minus, that is acetate ion, and Na plus. So at anode is the positive electrode. And this acetate ion will loses an electron and forms a radical. There are 2 lone pairs on the oxygen and a single electron, that is a radical, and we have this gives rise to a methyl free radical, and carbon dioxide is evolved. So here there occurs a homolytic fission, that is the electron will be shared equally, and we get a methyl free radical, and carbon dioxide is evolved. So this methyl free radical is highly reactive, and it will combine with other methyl free radical and forms ethane. So free radicals are highly reactive species and tries to combine with the other free radical and forms ethane. What happens at the cathode? So here we are taking 2 moles and 2 electrons are lost, and we get 2 moles of carbon dioxide, and 2 methyl free radicals will combine to get ethane. So here loss of electrons at the anode, loss of electrons is nothing but oxidation. So at cathode, the water molecule will take up the electron and we get OH minus and a hydrogen radical, and this hydrogen radical will combine with the other radical and form a hydrogen. So using this method, using this method, we cannot prepare methane. So you cannot prepare because methane has got only 1 carbon atom, so therefore we cannot prepare methane. So the next point to be remembered is we can prepare only the alkanes with even number of carbon atoms. So we have seen from sodium acetate on electrolysis with water, aqueous solution of sodium acetate, what we are going to get? Ethane. That carbon dioxide is lost, and if we have 1 carbon atom over here, then we are going to get 2 carbon atoms. And if you take propanoic acid, sodium propanoate, COONA plus. So there are 2 carbon atoms over here. So we are going to get 4 in the product, that is CH3, CH2, CH2 and CH3. So that is only symmetrical alkanes. Only symmetrical alkanes can be prepared.